Here's the question then. Let's have a look at, it's a circle question and straight lines in another circle. So let's have a look at the solution then. Okay, so find the center A, find the A coordinates and the radius of C1 then. So we need to write this in standard form. So let's have a go at that. A. So x, half of this is 1, so it'll be x plus 1 squared. And then we'd need, there's a 1 generated here, so put a minus 1 in. And then half of minus 6 is minus 3. So y minus 3 squared then. That will give us the y squared and the minus 6y, but we get a plus 9. So we need a minus 9. And we've also got a minus 15 in the equation. So what have we got then? We've got x plus 1 squared plus y minus 3 squared equals minus 10 minus 15 is minus 25. Move it through the equals to be plus 25. So here A has coordinates, then the center minus 1 and 3, and radius is the square root of 25. Okay, that's part A. Line L is this. Show that L is not a diameter of C1. Okay, well we need to show it doesn't pass through the center. Part B. When x equals minus 1 then, y is x, which is minus 1, plus 9, which equals 10. Y equals 10. So that's clearly not going through the center, isn't it? So L, line L is not on C. L is not a diameter, rather, because it doesn't pass through the center. Okay, good. Part 2, find the coordinates of intersection of C1 and L. So part 2. Here. Let's substitute in then. What have we got here for y? We've got minus x plus 9. So we've got x plus 1 squared. And then y minus 3. So it's minus x plus 9 minus 3. Minus x minus 3 plus 9 is plus 6. Plus 9 minus 3 is plus 6. Squared equals 25. So let's just expand that then. See what we get. X squared plus 2x plus 1 plus x squared minus 12x, isn't it, here for the middle terms, plus 36 equals 25. So we get 2x squareds. 2 take 12x's is minus 10x. And then the constant's 137. Move the 25 to minus 25. 37 take 25 is 12, isn't it? So that was 2x squareds. 2 minus 12 is minus 10. 137 minus 25 is 12. Here, when we expanded this, this was x squared, 2x and 1. This was x squared minus 12x plus the 36, and that equaled 25. Divide by 2 then, and we get a quadratic x squared minus 5x plus 6. Okay, so we're going to find the points of intersection here then, so let's factorize, hopefully. X and x. 6 ones minus 6 plus 1. It looks like, doesn't it? Let's check it. X squareds minus 6 plus 1 is minus 5. Plus times a minus. Oh, it's 2 3s. Minus 2 minus 3, isn't it? It has to be. That doesn't work. So we tried that. It didn't work. Let's try minus 2 minus 3 then. And we can see that that's going to give a plus now. So that looks fine now. X squareds minus 3 minus 2 is minus 5. Minus times minus is a plus. 2 3s are 6. So x is equal to 2 and 3. Those are the two solutions. So what's B part 2 then? Find the coordinates of intersection of C1 and L. We know that on the line L, y equals minus x plus 9, doesn't it? At x equals 2 then, y equals minus x plus 9 minus 2 plus 9, which equals 7, at x equals 3. Y is equal to minus the 3 plus 9, which is 6. Okay, good. So that's that. Great. So that's B part 2. So we got the intersection of the circle and line. Circle C2 is this radius. Find the shortest distance between C1 and C2. So let's have a look at that then. So we got, do a little sketch. This is part C. I just draw a quick sketch here with the digital pen. So what have we got then? We've got, okay, so what have we got then? We've got here minus 1 and 3 and radius 5. Minus 1, 3. I'm going to draw it slightly less bigger and radius 5. So that would be here A. Minus 1, 3. And radius 5. So just draw a circle around it really. That'll do. And that's a radius 5. And that was circle A. Now circle B. Let's have a look at circle B. 11, 8 and radius 6. 11, 8. 11 and 8. So up here somewhere. And we're going to do a radius 6. So I'm just going to draw a dashed circle for this one because it's overwriting some of the lines. So that's that. And that was 11, 8, radius 6. So let's get the distance between these two centers then. That distance there. This is B. So AB is a distance then. Square root of the other two sides squared and added using Pythag. 11 to 3. 11 to minus 1, this horizontal distance, 11 to minus is 12, so that's 12 squared, plus, and then it goes from 3 up to 8, so that's 5 squared, isn't it? Which is the square root of 169, 5, 12, 13, isn't it? 13. And the distance here is 5, this radius is 6, the total distance is 13, so smallest distance is equal to 13 minus the 2 radii, 11, which equals 2 units. Okay, so that looks like the smallest distance, doesn't it, in part C between the two circles, because the centers were 13 distance apart. This distance was 5 and this distance was 6 between the centers, so the smallest distance here would be the difference, 13 minus 11, which is 2.